Hello, let's talk about how to estimate the parameters of a categorical distribution. We have the likelihood, uh, we have the likelihood as this one, the log likelihood, the training set that has n elements, and we have the variables and the probability goes for k, and then this is the indicator function, which is going to be 1 if xi equals k. There is a constraint here that all the probabilities must sum to 1, and we can solve that using Lagrange. So we have the derivative with respect to pj of the log d and ki, and then you have Lagrange. And everything goes to 0. We can distribute the derivative the derivative I'm missing Lagrange here on the parentheses, and then let's focus a little bit on let's focus first on this one. And if we focus on that, what we can see here is that from all the sum, everything is going to be just everything is going to be zero except one element, which is when I can express that better. So just going to copy quite quickly BBK, just going to express. Then this is, then I can represent this one. You have lambda, and you have this sum. This sum can be represented like this one, j plus the sum of different than j I minus 1 equal to 0. So as you can see, when we distribute everything, I'm just going to use the red one. This one doesn't depend on pj, this one doesn't depend on pj, so this is 0, this is 0, and the only thing that it is the same one is the second part. So just going to copy. So you have my minus lambda. Okay, I can put lambda on the others in the other side, which is you have this equals to lambda. Now let's work with the other one, and we can follow the same approach. Like I'm going to change the products by the sum. So you have the first one is the sum of the n elements, then you have the sum for the variables, the outcomes. Then you then one half this one and log this one plus lambda. We can follow the same idea. So we can distribute. Then we can, okay, I'm just going to distribute the derivative. And then distribute the derivative, which is when it's j log j, and if I just sum by that one, then I have the derivative of the sum of everything that is not j. Now we can see, I'm just going to move this one, we can see that first I'm going to use another color. This is the variable that we are making the derivative with respect to that variable, and this is the only one that has p that looks like similar. As you can see, one depends on k, which never going to be j because of this. So it makes that all this element is 0, and that leaves us with the other one. And the derivative lambda, and then we have that the probability of this one is just 1 divided by lambda, the sum then we don't know what is lambda, but we can remember, if we remember the constraint, just going to show the constraint. This is the constraint. Remember that constraint? We can use that constraint into here, which is the sum. Then if I just make the sum, I need to make the sum in here. I wrote very awful this one. And just remember the constraint that makes the constraint is that is this one, talking about this one, so it's 1, meaning that this sum, just going to take out lambda, the sum, I didn't write that one, but that's for the sum for the other sum equals to 1. And then we can solve for lambda, and lambda is the sum for the And as we can see here, maybe it is something a little bit better if we type this like we have all the elements in the training set, and then we have the sum for all the d of all the d outcomes, and then the indication function, and just going to right. So this is fixed with this, and then we iterate for all the different. So for j equals 1 to d, we iterate, and we know that one of them it's going to be 1. It's going to be 1, and the rest is going to be 0, meaning that this is n by definition, and the final answer is that bj is 1 divided by n by the sum which is our intuition. So we are just making sure that our intuition it's correct. Well, if you have any question, don't hesitate in send me an email or asking me in my office hours.